Okay, so hello everyone. So last Tuesday, we have studied a little bit of introductions to power series. Before we continue the power series, maybe we can have some review, especially this part. So the strategy, the strategy for determining whether the series is converged or diverged is basically the first test that I suggest that you need to be more familiar is just use the divergence test. Okay? So whenever you have a series, any formula, check the limit. Okay? Check the limit of the sequence. Okay? Check the limit, and when you have the limit, it's not zero, then you can have final conclusion that it is a divergent. Okay? So that's the easy method that you should try at the first attempt. Okay? So the first trial, check the limit. If it is not zero, or if it is not exist as a limit, then you can write it's divergent. Okay? So if it is zero, then you need to check with other methods. Okay? The second method, or the second form that you can check, is the p test. Okay? So if you have 1 over n with power of p, and you know that p may be greater than 1, then it's converged. If it is equal 1 or less than 1, it's diverged. But the p series is just a simple form like this. Okay? So probably you can look more. Okay? So we can look more, and if the series appearing like the geometric series, then you can find the sum of geometric series, right? The sum of geometric series. And you will know whether it's converged or diverged through the ratio. Okay? And then the other part that probably still not too difficult is comparison test. So if you think the series is complicated enough, maybe it's too much formula inside, maybe you can compare the series with other series that you can find easily. Okay? Maybe you can compare with the harmonic series, the other p series, or maybe with other geometric series as well, okay, that you can find easily from the formula that you find. Okay? You can find direct comparison, or you can check the limit comparison. Okay? If it's not suitable, maybe we can just use another way, maybe ratio test or even integral test. But I'm not suggesting using the integral test. Okay? And if the series having the alternate signs, you can go directly to alternate series, okay, and check whether the series, the value getting smaller, and then the limit of this bn here is equal to 0. Then you can find how the series will converge or not. Okay? And the root test is for the series that is obvious, for the series that has the power of n. Definitely you need to just use the root test and check the value. Okay? Check the L, okay? Whether it's less than 1, greater than 1, or equal 1. But if it is equal 1, then you need to think with other method as well. Okay? So I hope you can get at least maybe 2 trials or 3 trials, and you find the way more easily. Rather than maybe you find the question and then you try some method but not really in logical order, and maybe you will it will take time. It will take time. But if you check from the easiest one, like the Divergence Test or the P series, if you check them, and if you can determine at the very beginning, I think that will be it takes really fast. Okay, the time will be faster if you check using this logical order. Okay, but again, this part here is up to you. Okay? You can, if you prefer ratio test when you look at the pattern, then you can check the ratio test after you check with the divergence test. You can go to ratio test directly, okay, if you think that this is faster for you. Okay? Because most of the cases they can be solved by ratio test. Okay? Maybe we can try for some examples. Okay? Maybe just take some examples first. maybe check with so this is just check whether it's converge or diverge. And of course, the important thing here is not only to determine whether it's diverge or converge. Okay? In your analysis, like maybe in exam, you need to at least write some statement, maybe some proof. Okay? Maybe if you answer this, oh, this is converge. Why? How? You need to explain. Maybe you can use maybe some task. You need to write the task. Okay? Maybe using the divergence test. Okay? If it's not proven, then you need to check with other tests as well. It's okay if you write the test and then it's not proven. You can write another one below that checking with another method. Okay? That's okay. It's like the algorithm within within our minds. Okay, that's okay. If in your TA class already give some questions that may be similar, maybe you can just tell me that, oh, we have done in TA class and we can skip. And to solve some questions, maybe more than one possible answers. Maybe possible methods, not answer, methods. Okay. You can have many ways to prove or to determine whether the series is convergent or divergent. So basically from 11.2 to 11.7, the main focus is to determine the series is converged or diverged through some several methods. Okay? And from 11.3, 11.2, 3, 4, 5, 6, they are all the methods that you study. Okay? And then from 11.8 to 11.10, we will focus more on the power series and its additional information about the power series. Okay, is it converge or diverge? Anyone get the conclusion? You can check the limit if you want. Still not sure, check with other methods. Okay. is not necessarily true. That's the important thing. Okay? So if you find the limit is 0, means it's not necessary to be converged. Okay, remember. But if the limit is not 0, it should be divergent. Okay? If limit 0, then you need to take another test to check whether it's converged or not. Okay, so probably my suggestions or my possible answer here is we can imagine this as being an as n squared minus 1 and n cubed plus 1. And then by looking at this n squared and n cubed, okay, we can imagine a comparison with 1 over n, okay, probably. Okay, but since we have minus here, I think we are not sure if we can do direct comparison. So we can go the limit comparisons. Okay? I think that is more logical, right? We can go the limit comparison because we know that if you have this is by itself is divergent series, right? It's harmonic series, it's divergent. This is divergent. And then what we are going to do is we can check the limit comparison test. So limit as n going to have infinity, and check an divided by bn. So we'll have n squared minus 1, n cubed plus 1, and this divide by 1 over n, so it should be multiplied by n. Okay, and we will have the limit n cubed and this will result in, this will become a 0, this becomes 0, this is 1, right? This is 1. So we have 1, which is, this is greater than 0. Okay. Remember, what we need to find is a positive number at the end, okay, that is greater than 0. Which means the conclusions are the both series converge or both series diverge. Since 1 over n is divergent, then our series is also divergent. Okay. Maybe we can go to another questions. Maybe I will give you two more examples. Okay, I think okay, maybe the next one is, this is A, this is B. maybe we start from the simple one. So again, the same questions, converge, diverge. Okay. I think this should be easy. Maybe giving you another questions. The third one. Same questions, conversion or diversion. For number B, any idea? What's the conclusions for B? Yeah. Converge or diverge? Diverge. Okay. Any other answer? Okay, I think it's okay, right? What you did is just take the limit of this. Okay? Take the limit. So check the limit using the divergence test. So check the limit. Let me write here. Okay, and what we are going to do here is, because it's limit, then we can use all the limit law or limit property that we already learned in calculus 1. So for example, we can directly go to L'Hopital rule because it's indeterminate forms, okay? Because it's indeterminate forms. So we can take the derivative, still e to n, and it's 2n, and then we take another one, and we will see that it's actually getting an infinite number, which means that the series is diverged. Since by divergence test, or it's too long, maybe just take the conclusions. This is diverge. Or if you want to make a complete answer, by divergence test. Actually, if you just take this statement here that is going to infinite, it's already okay. Then you can write diverge. That's fine. It's okay to answer like that. How about number C? Question number C. Okay, it has -1 with power of n. It seems alternate series, but look at the sequence here, the Bn. is it satisfies the alternate series? If not, then we'll be thinking another way. Think another way. This alternate signs doesn't mean that it can be solved through alternate series. Maybe it can be solved by other methods as well. Any idea? Okay, so the key to understand most of formula or any topics, especially in science, or calculus, or mathematics, is basically by learning by experience. So when you have some problems that you still can solve by your own, you need to try to solve it until you get it, like you can solve it by your own. Okay? If you just looking at maybe your friends or maybe some help from some websites, some online lectures, maybe they will give you the answers. But if you just take that as, okay, that's the answer, you don't really understand how to formulate the answer by your own. So if you can have that in your mind and you can practice that, eventually you can get all the understanding in the topics. Okay? Although perhaps it's not 100% you understand the topics, but at least 60 to 70 is enough. Okay? And of course, our scoring system, like in most of the university, like maybe in Asia, in East Asia, or maybe in Europe, or even in United States, usually we are using the GPA, but GPA is actually not really a good way to score the students, because there are a lot of aspects that cannot be valued in terms of numbers. So there are other ways actually. Maybe if you have time, maybe if you heard the news, like some schools like in Finland, like in some Europe, they don't really use the numbers like A, B, C, D to distinguish the students, because they have like they are all uniqueness in one student. So they have their, like maybe some students they have their own curriculum, some students they have own curriculum, like in the junior high and the high school. So it's not like teaching them, oh, you need to have a good score in math, or you need to have a good score in science. It seems that we still have that kind of maybe traditions, okay? Maybe traditions, like maybe sometimes parents like you need to be a good scientist, you need to be a good researcher, have a good salary, blah blah blah, right? But there's a lot of aspects that we still need to learn and need to maybe need to consider. Okay, back to here. So when we have this, okay, the takeaway, or for me, the shortcut for now is looking at the factorial. Most of the factorial, if you read the questions for maybe the textbook, most of the time they can be solved by the ratio test. Okay? Because the factorials, when you factor, it will be easier and you will be taken out with n plus 1. Okay? The factorial can be cancelled out with the other n plus 1. Okay? If you think about it. Okay? So most of the time, the formulation of the factorials can be solved by ratio tests. Okay? So if we take this ratio test, and remember, the ratio test, the formulation is having the absolute value, which erase the alternate signs. Okay? So you need to only figure out the value. Okay? So most of the time this will be a successful method, but there are a few times that maybe fail. Okay? When you have the equal 1 at the end, then you need to think of the other methods. Okay? So we can write this in terms of an plus 1. So n plus 1, careful, what you need to change is the n, not plus 1. That's wrong. So n needs to be changed with plus 1. So n plus 1 like this. Okay? So this part becomes pi 2n plus 2. Okay? And the bottom will be 2n plus 2 factorial. Okay? And then an, we can just write this is the 2n factorial, and then pi, and then 2n. And then remember the factorials property, okay? So if you have 2n plus 2 factorials, this means that 2n plus 2, and then 2n plus 1, and then 2n factorials, okay? So we can cancel the 2n factorials, and we can cancel this, and this is still pi squared, okay? So we have limit as n approach infinity of pi squared, and then the bottom one will be 2n plus 2 and 2n plus 1, which we can see that this is a constant and this is an infinite, so in limit this will be a 0. So 0 is less than 1, right? Remember in the ratio test, we can have this conclusion, right? That means that it's converged. Okay. So the series is we can write absolute convergent if you want, because we are having the absolute value, absolutely convergent or converge, just converge is okay by ratio test. So back to the factorial topics. Most of the time, you can check the ratio test. Most of the time. And hopefully it ends up with less than 1 or greater than 1. So you can finally decide whether it's converged or diverged. If it is equal 1, then maybe you need to take another way to check. Well, if you have like 6 methods, then the first method that you can try is the easiest one. And then if not, then the other one. And if it's still not logical enough to be solved, then maybe you need to think another way. Maybe when you check, it seems that it's not really, like I cannot really focus and conclude from this method, then you can just skip the method and check with other method as well. But if you're familiar with integral, okay, with integrations, then you can use integral test. I think that's be okay. If you prefer you are getting used to integrate something, maybe you can check the integral test. But to check the integral test, you need to have your functions to be continuous, decreasing, a positive function. That's the thing that you need to include in integral test. So that's why it's the last option for the method. Okay. Okay, I think we can move on to our topic, the power series. Okay. And if I have time, maybe later on, after we finish the chapter 11, maybe we can have some small review and having some practice. Okay, so back to the power series. Okay, so we learned that we have this x minus a. So it's not just x, but we have x minus a, which means that we can have some interval, okay, in terms of x and a. Okay. We have a distance. We have some distance. Okay. So, for example, the questions will be what values of x does the series x minus 3 with power of n over n is converged. Okay. The previous sections about series and all the methods, we are not including x. Okay? And now we are having x, so that our convergences have an interval. Okay? If you can imagine. Usually we can have like, converge to some number, half, 1, 0, blah, 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 right? We can have some numbers. But our numbers, in terms of this series now, we have some interval. Okay? We have some interval. So we have some interval of convergences. Okay? So the thing here is the method you have learned before. We can use all the methods, okay, to check whether it's converged or diverged. Okay, but the difference is we are going to have some x now. Okay, so if we let the an as x minus 3 over n, okay, and then we can just use the ratio test. Okay, the ratio test. So ratio test, let me copy this and write in the new slides. Okay, if we let this an and then ratio test,
take an plus 1 over an. This will result x minus 3 n plus 1 and then n plus 1 and then n and then x minus 3 and then n. So let me just write the comparison first, and then at the end we can take the limit. Okay, we can have that at the end of the results. So we can check this, we cancel this out, so this is x minus 3. So we will have x minus 3 and 1 over 1 plus 1 over n, right? And from here, if you take the limit, here for n, this will result in 1. Okay, so as n going to be infinity, the ratio is going to x minus 3. So that means we have some interval so that we can have x minus 3 to be converged x minus 3 need to have less than 1, okay? And diverge is when x minus 3 is greater than 1. Okay. And this will become or we have the interval of x that is takes the series to be converged. We now have the interval. So when it's going to have from 2 to 4, which excluded 2 and 4, the series will be converged. So basically, what we did is the same or the similar method with the previous series, like we have learned before. The difference is we just have this x. Okay? This x will, at the end of the results, we will have some of x will be converged, some of it will be diverged. Okay? And most of the time, we are using the ratio test most of the time. So this is diverged when x less 2 and x greater than 4. Okay. So we are having these two category of convergences. And we still not clear whether which one is converged. We need to check also if this x minus 3 is equal 1. So either we have x equal 4 and x equal 2. Okay. So we need to check one by one, 4 and 2. Check to our results, okay? So if x equal 4, then it will be an will be 1 over n. And when x equal 2, then it will be an will be negative 1 with power of n divided by n, right? 1 over n is diverged, right? The harmonic series, the p series, is equal 1, it's diverged. This one, alternate series, converged, right? So this one is converged, the alternate series is converged, and this one is diverged. So the whole interval that we can conclude from here, the convergences, the two need to be included. Okay. So the conclusions, to be a converge or convergent series, the power series or maybe it's not series. Maybe we can directly write to be convergent, the power series will be converges for 2 less equal x less 4. Okay, I hope you get the logical order, what you need to do. Okay. Let me just take some time to review from here. Okay. Okay. Imagine this is not having an x, so we have like a number. Okay. Maybe the alternate series, or maybe some number there. Okay, a constant, right? If we have those series, then it's just like usual series. We can have a comparison test, or maybe we have the P series. Okay, we take some time and we know that whether it's converged or divergent. Okay, but now we have this x. Okay? What we are going to find is now the answer is not only saying, oh, convergence is some value, but the convergence is in these x terms, we have the interval, okay, to be converged. Now we can have the ratio test using this x minus 3, and we can check with n plus 1 divided by n, and we solve this through ratio test, and we have this expression. We know in terms of limit, this is equal 1. Okay. So we are just looking at this absolute value of x minus 3, which we can relate to the conclusion in ratio test. The conclusion is having 3 conclusions. We can have converges, which is less than 1, diverge when it's greater than 1, or inconclusive, which is equal 1. Okay. Now we can have this. Okay. Maybe you get this. Oh, convergent is 2 less x less 4, and this is your final answer, which is it's not necessarily true. So you need to check the other conclusions. X minus 3 equal 1 is inconclusive, which means by inconclusive is we need to test x equal 4 and x equal 2 to our original question, whether it's converged or diverged. Okay? So we check one more time, and then we conclude that when we have 4, it's just 1 over n, right? It's 4 minus 3 is 1, 1 with power of n. You can say it's just 1, the constant, and 1 over n is divergent harmonic series. When we have 2, we have an alternate series, which means that it's converged. So that means the final conclusions to be a convergent, or the power series to be converged, we need to have 2 less equal x less 4. And then this is final conclusion. So the problem in this power series is we are going to look for some interval on the convergences. Okay? And most of the time, we are going to check the series with ratio test. Okay? Most of the time. Okay. Okay, this is one example. Another example, and from this example, we can have some conclusion later. Okay, some conclusions. So the series is n factorial x with power of n. So the question is the same: what values of x does this series to converges? Okay, we can directly go through ratio test. So let me write n plus 1 divided by an. This will be n plus 1 factorial and then x n plus 1 divided by n factorial and x with power of n. Now we have n plus 1 factorial is n plus 1 and then n factorial, right? And x, right? Okay, and then we can simply cancel n plus n factorial, cancel. X with power of n, we cancel that. Okay. So we will have x and then n plus 1. Now we can have this limit as n approaching infinity. Now the questions, what number of x or what values of x the series is convergent. Now if we look this limit, this n plus 1 as the result, of course this limit is getting infinite, right? Getting infinite. Okay. But if we look at the x, what values of x so that the series converge? Yes. So if the x is 0, then it's getting converged. Okay. So we have two elements now. We have two elements. Elements of x and elements of this, the n, the integer n. Looking by this limit, if the limit having infinity as a conclusion, then the only x that's possible to be converged is only 0. Okay. So we can conclude the series diverge when x is not 0. And the series converges only when x is 0. Okay, we may have some break. Okay, so this is the second example. Okay, so the first example, we have some intervals. Okay, we have some interval of convergences. The second one, we have the series converge only when x is equal 0, right? Or if this is maybe if this x is maybe x minus 3, then the x will be 3. So just at one point. So the convergences is only at one point of number. So the next example is the series of have two n and factorials. Okay. So what values of x? So the series converge. So what values? The same questions. What values of x does the series converge? And then similar with the previous examples. So first we can take the ratio test to check the convergences, and then later we can check which x that the series is converged. Okay. So we check a n plus 1. This will be x n plus 1, and then this will be 2n plus 2. This is 2n factorial. This is x with power of n. And then we can try to solve. this one is just x, this is cancel, this is cancel, this is cancel, and we have 2n plus 1 here, right? This is actually 2n factorial, and we cancel this. Okay. And then we have squared the absolute value of x, and then 2n, or maybe let me write absolute value of x, and then limit Sn approaching infinity of the 1 over 2n plus 2 and 2n plus 1. And we will have that this should be resulting 0, okay, because of the 1 over infinity, okay, that becomes 0. That means every x we are going to input, every x we check any number, it's still going to multiply with 0, which means that all x will be converged. Okay? All x will be converged. So this is less than 1, right? That means that this is converges. So the series converges for all values of x. So all x will be converged. So from this example, these 3 examples, from the first example, second example, and the third one, we now have at least 3 possibilities. Okay, 3 possibilities. This is called the interval of convergence. So for power series, there are 3 possibilities. Series converges only when x equals some value. Like the example x equals 0. That's one example. And second, series converges for all x. This is what we did the last example. Okay. So if we find the limit at 0, then all x will be converges. Okay. And the third one, that is we have the interval of convergences. Okay. So we call that there's a number, let's say R, such the series converges if and diverges if it should be a positive number, sorry. This should be a positive number. Because this should be represent the ratio test. Okay? This should be represent ratio test. So why we did ratio test all the time? Because basically that is the way we are going to observe our power series. Okay? So this less R or greatest R is similar to what we did in ratio test. Okay? But now we are having the terms R, which means R is the radius, our radius of convergence, or the interval of convergence in general. So R is radius of convergence. of the power series. So radius means the distance. Okay? For example, x minus 3. So the distance will be, at least they need to be have 3 or 3 to the backwards or forwards. Okay? But the interval means that you need to plus or to minus those distance. Okay? Let me just explain later on. Okay? Okay, let me go put the graph. Okay, the graph is let me take it a little bit bigger. So meanings, when we deal with the R, or radius of convergence, we have the interval. The interval is the total interval we are going to observe. Okay? The radius is just the distance. Like for example, this one and this one is the radius. Okay? This is the number A that is in our observation. So we have, at least, there are several possibilities. Depends on what we did. Like the previous example, like we have here, we have this, right? Which includes the left endpoint. Okay? That means we are having this, right? Okay. And there are more possibilities. Like it depends on the cases. Okay? We can include all the numbers. Like we have this, okay? Or maybe we are not including the numbers itself. Okay? So I hope you can get the idea from here what the radius means. It's a radius means it's the distance between the number that you observe, the A, and the distance on the interval itself. Okay? Either it's A plus the R or A minus R. Okay? And in more practical, there are several series that probably we can take a look on how the radius and the interval will be. Okay. Okay, let me go through the next one. Okay. Okay, maybe first we can look the geometric series x to the power of n. Its radius will be 1. Interval is from -1 to 1. And this is our example before, our 3 examples. The first example, we have x minus 3 to the power of n multiplied by n. And as we write down the answers, the interval will be include number 2, right? But the radius is just 1. Okay? The radius should be from here. X minus 3 is less than 1. We are not having any changes in this one. Unless if we have 2x, maybe 2x minus 3. 2x means that we need to divide 1 by 2 so that it becomes x. So the radius will be half. If it is just x, then the radius is just 1. Okay?
And then the example 2, we have the radius is 0. Because we are only having 1 point, right? 1 point of convergence, which is just 0. So there's no distance. The last example, it's all x, so all numbers. So the radius becomes infinity. The interval becomes from all points of x. Okay. Now perhaps giving you more example on finding the radius and interval of convergences. Let me give you another example that is more likely to give you an idea. Okay. The question is just to find the radius and interval of convergences. So basically, the first thing you need to start is check with the ratio test. Okay. Check the ratio test, and then look the form and look the pattern, and take times to check which one is going to be converges and which one is going to be diverged, and then focus on the converged one. Okay. Find the radius, find the interval. So first, let's write the ratio test. So by default, this is the method that we are going to work on. Okay, then we can solve, and takes time. So solve this, and we can separate and group one by one x and n. Okay, so first we can write down the x. The x will be minus 3x, and then we have another one is the n. Now we can have this 3x and then take limit for n. This will be equal 1, right? This will be equal 1 for the limit. So we have 3 absolute value x for the ratio test. And from this 3x, we are going to observe how the series can be converged. through this X.
So converges, or maybe series converges when 3x is less 1, and diverge when 3x greater 1. Okay. So first, if we look on the convergences, we can simplify. So x, so maybe it's converges when x is less 1 over 3, and diverge when x is greater than 1 over 3. Okay.
Now this 1 over 3 becomes our radius. Our radius of convergence. The distance becomes 1 over 3. So we can say that from here, we can make a statement that the radius is 1 over 3. And we know the interval, okay, for convergences, at least the interval is negative 1 over 3 and 1 over 3, okay, from here. Okay. The next step that we are going to check is we need to check whether we need to include this number or not for the interval. Okay. So we need to check.
So we need to check if x is negative 1 over 3 and x is 1 over 3. So let's check one by one. I think I need this. So the first one, if we check it's negative 1 over 3, this will be negative 1 over 3 with power of n, and then this will be square root of n plus 1. And this will be, we can simplify this, and we will have a series which have the 1 over square root of n plus 1. And if we look here, this is a P series with less than 1, right? So we can have this is a diverge. So this is a divergent series. When x is equal 1 over 3, then we have so we will have negative 1 with power of n, and then we have square root of n plus 1. And then if we look on the alternate series, the sequence will be smaller in value, and the limit is 0, right? The limit is 0. So we can say that this will be converged by alternate series. And then finally, from these two conclusions, from these two results, we can conclude the given series or the given power series converge when negative 1 over 3 plus x less equal 1 over 3. So the interval of convergences will be from negative 1 over 3, negative 1 over 3, and 1 over 3, but we need to close interval.
So we need to check our steps one by one, okay? And then of course, we need to check these convergences and divergences by method that we have learned, right? So we can have the PE series, we can have the alternating series comparison test for checking this series. Okay. And lastly, we can have the final interval for the power series. Okay. So I hope you get the order, okay? the logic order, okay? how we can observe from the series. Okay? So basically, this is just a similar series that we have done. Okay? The difference is we just have another x that we need to find. So we have some interval for our convergence. Okay? So the convergence is not really going to have like one value, but it's rather it have some interval. Okay? I think that is the power series. So the power series will have to observe there are interval on your convergence of your convergences that you need to analyze. So I hope the logical order from the first step until the last one here is clear. It's clear. Is there any questions? Any questions? Any discussion? Okay. Okay, maybe we can look on divergence and convergence. It's not about just how we can see the numbers, okay? But sometimes in other maybe social or maybe philosophy, they will also include how to deduce the arguments. How to take the logical arguments, and sometimes we need to have some methods, and actually sometimes we need to have some certain pattern, logical pattern, and if you're looking on this how we can find the convergences, that is there are no clear statement which one is true, which one is not, and we need to deduce that and taking into some interval. Okay? But in math, in calculus, we're taking all the terms into a number, set of numbers as our language. But in other subject, maybe not a number, maybe a pattern, maybe like your DNA, you have pattern in your DNA, right? You have a statistics in your body, maybe in physics also as well. So the term is just inter-exchange ability of the language. So when we have the math calculus, our language is using the numbers. Okay? Because numbers, set of numbers is the basic fundamentals in mathematics. Okay, I think we can go to the next section. Just an intro, because it's related to power series also. And maybe after that, we can have review or some practice in the textbook, maybe one or two examples. Okay, any question, discussion? What if x equals 0? You mean this x equals 0 is like this example? Here. You can have x equals 0 if the limit getting infinity. Okay? So if the limit getting infinity, then the possible way is x need to be 0. So there is only one solution. Okay. So there are no really radius and interval. So we can say that for this one, we can have this example as just one number 0, x is 0. Or maybe some number as well. Maybe the terms is not just absolute value x, maybe x minus 3. So maybe the only number is 3 to make it 0, right? So maybe we can have 3 here. Or maybe x minus 5, so this will be 5. That means the convergences is just on one point, not having the interval. Okay, any other questions? Okay, I think we can have more question and answer for the power series after we have some introduction on the next one. Okay. So let me just take some last 10 minutes because on the last 5 minutes I want to have some small review. Okay, so the next part is the 11.9. It's still related to power series. We call this is representations of functions as power series, which translates, okay, if you difficult to see the words, this means that we can take the power series and make it into a function. Okay. I think we have studied or observed this 1 plus x squared plus x cubed plus ... and we can take this as a series of x with power of n, in which we can relate this to geometric, right? Geometric, because this is the ratio is actually x. The common ratio is x. So we can say that this will be equal with 1 over 1 over minus x if, okay, if x is less 1. Or it's between -1, x, 1. Okay? So we can take this as our first observations. So we can say that this series x with power of n, and when the absolute value x is less than 1, is a power series representation of 1 over 1 minus x on the interval -1 to 1. Okay. And if we try to observe the series as a partial sum, okay, we can take the 1 over 1 minus x as a limit of the partial sum of n term of x, where the partial sum is 1 plus x squared plus ... plus x with power of n. Actually, similar approach as we begin the series. Okay? When we have the sequence, the series, and when we try to develop or establish the series, we are having another observation in partial sums. Okay? So it's actually similar approach. So then we have the partial sums, okay? And if we put into
if we put into a graph, okay, so this is a graph of 1 over 1 minus x, and the s means that the partial sum. Okay. So you'll see when we have s2 means that 1 plus x squared. Okay. So if we check here, it starts with n equals 0, right? So n equals 0 is just 1. So if we start from s1 means 1 plus x. If we start from s2 means 1 plus x squared. And then we can try to draw the graph. So when we try to draw a graph, this is s2. Okay. I think it's logical, right? It's just a quadratic, okay, quadratic functions. And then when we have 5, we have a symmetric, right? Symmetric to it's going down here, right? Going to negative. This is an odd, right? Odd functions. S8 is an even function. But when it's going to have like larger and larger n, when you increase your n, it's 8, 11, and then you have these original functions of what we have approaching. So we can have this as n, maybe as n increases, the Sn, or the partial sum, becomes better to approximate the functions for -1, 1. Right? So we are just looking at this interval. Okay? The other interval we are not really observed because this is what we really care, the interval. Okay? So fx is 1 over 1 minus x. Okay? So if we can take these functions 1 over 1 minus x into power series x with power of n, we will have another set of functions that we can take that functions and we can make another series. Okay, so that's our goal for this section actually. So this is our first approach, 1 over 1 minus x, that will correlate with the series x with power of n. So let me write this conclusions. That is, this is okay. This is the first step, and the graph is just to showing you how the partial sums will visualize, and when we increase the n, it will goes to approximate the functions. Okay. So if we have another set of functions, okay, let me just take one example and then, or maybe two examples. Okay. Okay. Let's look the 1 over 1 plus x squared. So if you want to express this in terms of series, what we are going to do. Okay, first, what we have is 1 over 1 minus x, right? this is getting x with power of n. So the suggested answer will be, we can take this 1 over 1 plus x squared as 1 minus x squared to match the forms of the one that we know before. Okay. So then we can take this and then take the series that usually it's just x. Now we have negative x squared. So we have negative x squared with power of n. And we can manipulate the series, taking negative 1 out to make it clear, and then x with power of 2n. And this is our series now, the alternate series, in which we have 1 minus x squared plus x4 minus x6. And because this is geometric series, right, with r is equal negative x squared, okay, we will have the converge. So the series converge when this absolute value of negative x squared is less than 1, or that is the x squared should be less than 1, or x is absolute value of x is less than 1. So the interval of convergences is negative 1, 1. Well, we can also check the with ratio test for the series here to check the convergence, but I think no, not really necessary. Not really necessary. Okay, the other questions, find power series representation for 1 over x plus 2. And still the idea is still the same. What we have is 1 over 1 minus x. So we need to force the 1 over x plus 2 to take the form of 1 over 1 minus x. Okay. So we need to at least factorize 2 first, right? And then change the plus into minus minus, right? So we can take this 1 over 2 plus x, and then we can take the 2 out. So we'll have 1 plus x over 2, right? So let me just write 1 by 1. And this will be 1 minus x over 2. Okay. And this one is our series. We just need to multiply with half series of this negative x over 2. So this will be half, and then this will be the series. And write down the series like that. And then we can simplify and take negative 1 out. So we will have 1 over 2, the sum of -1 with power of n, and then 2 n plus 1 x with power of n. Or maybe this is not used anymore, okay, because I included inside.
Well, you can just write half, and then maybe this is becoming -1 and 2 with power of n. That's still okay.
But the complete answer,
all the terms should be inside the sum. Okay, so sum and then all the numbers already integrate inside. Okay, so the idea still,
let me just write the idea so that you don't forget. That the idea is from this, okay.
So what does it mean is,
If we have
different x here, then we just exchange this x with those numbers. Okay. If we need to take some time to manipulate the form, like we have 2 here, then which means that we need to multiply half at the series, okay, and then we can include the constant inside and make a new series. So basically, we are just taking our time to manipulate this representation. So this is the first section on 11.9. Representations of 1/1 minus x. Okay? We will continue later on next week for another representations and also some review on our series.
But now what I want you to do is we will have some small review. Okay, with some small review. I need you to log in to
the Mentimeter. We haven't do this activity for I think quite some time, so I need to check. Okay, if you have trouble to join using the QR code, you can just go to the website, entering the code. I will wait maybe up until some participants, okay, 13, 15. Okay.
I think we can start. Okay, I hope you use your student ID, okay? But if you use other names, and that's still okay. Okay, I hope that the time enough.
Just a simple question. So 4 questions, all simple questions.
Okay.
If the sequence decreasing and is positive,
Okay. Okay, that's the definitions for the sequence. Okay, the first section in our chapter. Okay. Okay. Oh wait. Okay, get ready. You can use several ways. I think maybe 2 or 3. Yeah, I think 2 or 3 methods. But for now, you can choose easily converge or diverge. But when you have an exam, then you need to take some time to prove. Okay, to prove. I think it should be obvious if you see the formula. You can use comparison test. Okay, you can use comparison test. Yeah, use comparison test. Either limit comparison test or I think direct comparison test also. Okay. Okay. Question 3. Okay, I give you a little bit too much time here. I think it should be 1 minute. And you will notice that this pattern is pretty much obvious if you see the example that I gave before. Okay, 25, 26. I think a little bit. Okay, everyone has voted. Okay, I think it's easy. It's just using the ratio test thing. Okay, took over the throne. Okay. Okay, well, last questions.
but not the last from all. Okay.
We still have some survey for you, just a simple survey. But this is the last question for the quiz, for the review. Okay, should be obvious. Should be obvious. Okay. I mentioned before. I think around half hour ago I mentioned this one. Okay, good. You noticed that. Okay, a little bit survey. Let's see who's the winner. Okay, who? Okay, okay, congratulations. Okay, some survey, a little bit survey. Okay. Left is disagree, right is strongly agree. You can, I think, pick some scale. I just want to know whether the chapter 10 is okay. And what's your opinion of your first quiz? And maybe. Okay. Have you? Okay, I will move to the other one. Still some simple survey. Okay, yes. Any improvement, any suggestions you want to write, please? Okay. Maybe some part of my lecture still confusing, or maybe still need to be elaborated. Okay. So what do you think about course so far? So, or do you need to have more practice, or maybe improvement on the TA session? If you think so far so good, and you can write so far so good, or it's okay, or it's really fine. Okay. Oh yeah, additional video. Okay. For chapter 11, maybe I will put some additional video. Some additional video. Like chapter 10, I put some 2 or 3 examples. Oh, are you here? Okay, there is a quiz on your TA. Okay. Yeah, I don't know the schedule why it's so early. Okay. Okay, if you have done this part, you can go out. Okay. And see you next week.